I'm CK. Today we've got another project from Whadda that I picked up from jamco.com. It's the Panda Plant Guardian. Looks like a little device to let you know whether the soil in your pot is too dry or whatever. Probably a little resistive circuit to see what's going on. So we'll put it together, see if we learn anything from it, see how much fun it is, and how it works. And I hope you enjoy the video. Here's the box. Typical Whadda vellum box. Overwrap around another box so they can use this same box for a bunch of different things. It's got a little plant, soldering iron, level 2, so not the simplest, but not very hard. The Panda shows if your plant is okay, too wet or too dry. Moisture sensor probes, adjustable sensitivity, red, green, and blue LED indicators. And takes two 2032 batteries, which they didn't include, bless their hearts. Then we've got the stuff that makes it up, and a QR code for the manual, which we'll see. They often have a piece of paper in here. They might not. They might have completely stopped doing that. So I gotta pull the pull tab off, reach in, and wow, it's big. See how big that is. I mean, ear to tip stake. Tip is 140 millimeters, or 5 and a bunch of inches. 5 3/4 inches about. I see here. Looks like the LEDs go in here. Diode here, resistor, 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 resistor. None of the values are marked, so we will need a build guide. So, okay. These are 2 variable resistors, and you may be able to see here. Let me try and make sure that's focused. It's got a range indicator. We'll learn about that. That's battery. Looks like a battery for both sides. Or maybe they're in series. Let me look at the traces more closely up. I can't see them that way. So the traces are going. Yeah, they're in series. And we do have a piece of paper to tell us how to put it together. Double checking everything's out of the box. We'll get the box ready for recycling. All the warnings. And typical vellum directions, and they want you to, looks like they want you to test the battery holder once you put it in. The trimmers, diode, IC socket, LEDs. These are multicolor LEDs with 4 pins on them. And then a chip, thumb wheels for the pots. Oh, they have a calibration video online. I don't know whether I'm going to watch that or not. We'll see. I may just fiddle with it. So that's it for all the bits and pieces. Let's see what we have in the actual bag. We'll dump it out. Take a look. We've got the IC, and if you'll notice on the IC, there's a little, somebody put a little yellow highlighter on there, which is to indicate that it has been programmed. There's the LED. Let me see how. I don't know how they spread out. Oh, okay, we've got the diagram for which pin number is which and what holes they go into. What's the... I'm not going to do that. And the knobs for adjusting the pots are pretty big. That's nice. So that's it. I'll get the soldering iron heated up and we'll put this thing together. Let's put all the components on. Shouldn't take too long. Now, could be a little confusing. This says front side and this says solder side, and some things you might say, oh, so everything goes on the front and gets soldered on the back, but no. If we look at the picture, zoom down in a bit on that, up, go the other way, silly person. Where is my pointy thing? There it is. If we look here, you'll see that the LEDs go on the front, the IC goes on the front, but the resistors, diode, battery holders, and the two potentiometers go on the back. So now we've got that sorted out. Let me back this back off a little bit so you're not completely in our face there. We'll do the resistors first. And we're going to do R1, which is, let me get these all sorted out on the table actually. Yeah, it's an interesting question. I think, yeah, each we've got, unfortunately, it's got a two-level board. Get all these sorted out. Find the 1K, brown, black, brown. I mean 100 ohm. We'll just double check it. I want to look at the tolerance on this also, just because it's always fun to take a look and see how good the resistors are. .9, so 98 ohm, not 100 ohm, but pretty close. And since it's gold tolerance, and 98 versus 100 is 2%, I'd say that's pretty good. Pick that up so we make sure I don't have any resistors stuck on the back, and that goes in R1, down here. The smoothest edges on the component holes. I'm going to solder that one right now to get a feel for how this takes solder. Oh, just fine. Does just dandy. So the rest of the resistors will go on the same way. So I am going to speed up the playback and cut out some of the activity also along the way so you can enjoy resistor time. So that's all the resistors, not very many. And we're going to put the battery holder on now. Battery holders. And they go on like so, and like so. And we're going to not solder them on this side, we're going to solder them on this side. Oh, and I see, I missed something. They wanted us to put a drop of solder on the pad. I didn't know what that meant. I thought those were meter leads, not the soldering iron leads, so I'll just go in there and put that in there anyway. A drop of solder just to give it, I believe it's just to give it a little height to make sure we're making the actual connection. But that was easy. You can see them in there, little solder drops on the center pad. Now we're going to do the trimmers. And these should, oh no, they're not bent pins. Huh, okay. Typically these have little bends in the legs that allow them to stick into the holes without moving, but these don't. That's okay. Just lift it up on one end. So I'll put some foam under there to make sure these are all flat. And I'll just do one leg of each to start. Now pick it up, take a look, make sure these are all flat. And they are, so I'll do the other two legs. I'm going to do these on the back because I'm not sure the solder bled through. I'm not seeing the solder bleeding through. That's the thing about through-hole boards, you can check and see if the solder wicked through to the other side. You can see when the solder goes through, and that means it's a good solid connection. And I wasn't certain about those, so I decided to put a little solder on it just to make sure. Now we'll put the diode on. It's 4148. Oh no, this is a bat. This is not a BAT 85. It says it's BAT 85, but this is not. This is a 4148. No, it's a BAT 85. It's just a different color than I'm used to seeing. So there's a black line here, and that'll go against the black line on the circuit board, or the Panda. So we make sure we have our polarity right. They did not use the right stencil for that diode. It's so, the whole position is so broad, and the diode is so tiny there. I think they were using originally the blue and black BAT 85s, which are bigger. I'm just going to do this on this side because that's where it is, and I'm not too lazy to flip it over. That sound you're hearing is my house water pump running. Somebody is using water in the house. So my boost pump kicks in because I'm way out there and I don't have good water pressure, I have to have a boost pump to give myself enough water pressure. Put the socket on, notch to the notch on the circuit board. I'm going to rest this on my pinky finger. Actually, I'll rest it on the mat, on my solder mat, and just do one pin. Check to make sure it's all flat, and it's not completely flat, so I'm going to reheat that solder ball and push the socket down and let the solder cool, and now it's all correctly in place. Now I'll do the rest of these pins. Now I'm going to do the LEDs, and again I've got set it like this. This is pin 1, pin 2, pin 3, and pin 4. So let's see how the best way to do this. One will go actually we'll go 3. It's a little confusing. I'm sorry if I'm fumbling a little bit. 4 will go back a little bit this way. 4 will go back that way. 3 will go this way. It'll be 3 and directly opposite it is 2, and 1 goes over to the top hole, and 4 goes to this. Oops, I should have done 4 before 1 and 2. There we go. So it'll go like that. It's a little twisted. It's not going to go all the way flat because I'll show you here in a second. The eyeballs are going to stick out a little bit because on these, let me zoom down. On these LED legs, there's a little flat part here, about 3.5 millimeters down from the base, that's been flattened and broadened a little bit, and it won't go through the holes. That means the eye is going to be sticking out a little bit. Okay, let me go back a little bit. Now we'll do this other one. I'm going to put the 2 control wheels in, squish them into place. They friction fit in very easily. Now we'll put the IC in. Again, it's got the stripe on it showing that it's programmed. Bend the legs in just a hair against the side of my table. Put the notch by the notch on the socket and the printing on the circuit board. And there we go. Now I'm going to go get some batteries and maybe get some potting soil or something to test this out with. But that's all the build. That's all there is. Pretty simple. But fun. Back in a bit. Okay, I've reconfigured my cameras so we can get a better look at this. And what we're going to do, this is our plant. I put some potting soil in there. I'm going to put a little bit of water in it, like we've freshly watered our plant, or watered the plant recently. Just a little bit, not a lot. Now we'll put our batteries in. They're 2032s. I use rechargeables in my shop, so I'm not throwing batteries away all the time. The plus side goes against the metal bracket. Now we get it on. We turn these fully down. Okay, there is our little panda eyes lighting up. Now we're going to put it in about there. And what the instructions say is now we turn this up until it just flickers. So there, it's flickering. Now we set the range. We should go turn it until it's green, showing it's well watered. That's fine. Now if we pull it out, it goes red because it's dry and there's no conductivity. The resistance is way too high. It's infinite there. There's a little bit of resistance there. I mean a little bit of current flow there, making it green. Now if we go into this full cup of water, that's supposed to go blue, indicating that it's overwatered. Well, I guess if we put it kind of there, checking the center. Now it's blue, now it's red, and now it's green. Okay, so you got to tweak the center, which is this ear, and the range, which is this ear, to get the right. So no water, red, good amount of water, green, way too much current flow, very low resistance, so it goes blue. Except now that's not blue. Red, green, blue. So that's how it works. The hardest part on this was actually calibrating it like that and getting a pseudo plant. But it's a good kit, goes together very quickly. You can learn about resistance between these two probes, that water and soil lowers the resistance of the soil, so it actually allows current to flow between the two probes that's in the water. That's why, by the way, when you talk about earthing and grounding, that's where it goes. It goes into the ground. That's why there's a big copper spike in your yard to provide a return path back to the generating station. Same thing here. Earth and water, or potting soil and water, make it slightly conductive. So that's it. A good little kit from Whadda Velleman, and I hope you enjoyed the video.